Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net. Episode 17, Java. Take it away, Patrick.
All right, mixing it up this week. So, having a young daughter and talking to other people at work with young kids, we got into discussion the other day, which I thought was interesting, about playing video games with your kids. So obviously my daughter is far too young to play video games, unfortunately. It'd be a nice excuse to play even more video games than normal.
Yeah, well, I saw a 1-year-old playing Angry Birds the other day.
Were they doing it well?
They weren't doing too bad. I mean, like, in other words, like, the bird was moving. You know, they weren't getting a high score or anything. But, like, you know, they could see that. I think the 1-year-old was starting to figure out that, like, you know, if they moved their finger a different way, the bird did something different. They were kind of starting to get the whole, like, the bird doesn't go as far if you move your finger down or whatever.
Oh, wow.
They were doing I was impressed. I was shocked.
That's pretty good. Yeah, it's a hard thing. So, there's different classes of games. You can try to play like an educational style games. Like I remember growing up, you know, you had these games which would teach you math. You know, you would run around the level and try to hit the blocks.
Yeah, like the Cookie Monster one where you had to like add the cookies.
Yeah, and there's all these, you know, but those are kind of overtly educational, right? Like obviously you're learning, you know, and at the expense of gameplay. And then there's like trying to do gameplay that is, you know, truly engaging for a kid. And maybe trying to mix learning in it. Like, I guess there's some learning to be had in Angry Birds, like you said, like trajectories type stuff. Yeah. I mean, that's kind of interesting. I don't know how much a 1-year-old cares about trajectory, unless they find a slingshot.
But maybe, you know, yeah, it's like the bigger thing of like the consequence of like, or just knowing that like there's this spectra here. Like if you go like too far on one end and you go too far on the other end, next time you go in the middle or something. I mean, like there's some core concepts there.
So I guess my debate was how soon, you know, not that it's a big deal, but, you know, how soon do I want to start introducing video games? Because if you see like a 1-year-old playing Angry Birds, they can maybe play it, they can launch the bird, but they're not really understanding it.
Yeah, that's
true.
So,
I mean, if they're enjoying it, okay. Are they learning anything? Is there something you could be doing that would help them learn more?
Right.
Does it matter? Like, you know, these kind of questions, because when I was hanging out with my cousins a while ago, one of them had a Nintendo DS and the Super Mario on the Nintendo DS. And of course, you know, when I was, you know, young, first, second, third, fourth grade, I don't remember when we started having video games, but when I played, you know, Mario or whatever, I would get to the first level, second level, and then, you know, die, and there was no save games, and I would just play it over and over again. It was really difficult. Now I can play and like, yay, I can get to level 5 before dying. No.
Exactly.
So of course, you know, my cousin thinks like, oh, you know, Uncle Patrick's amazing at, you know, playing Mario. I'll have him beat this level for me. But then, you know, it's like, it doesn't help them because they observe me play, but it's all like the subtle timing. So then every time they get stuck, instead of like toughing it out themselves and learning, they just want to ask me like, oh, hey, can you now beat this? Like, no, you know, either I'm too busy and I don't want to, or like, you know, this isn't helping you, me just keep beating these levels for you. Like, you know, you're not getting anything out of it. But like there was a long time before I was able to ever like get a game to where I could beat it that wasn't a kid's game.
Yeah, one thing that's kind of weird is I went back and played some old games on the Wii Virtual Console.
Okay.
So, you know, went back and bought Mario and Zelda and stuff. And I was actually much better at these games when I was like 9.
Yeah. You remember them being like incredibly difficult, and now they're
But even more so, like I remember being way better at them.
Oh, you were better before.
Yeah.
Oh.
Yeah. Like I went to play, and I think what it is, I think I had more patience because the cost is high, right? Like if you know, you're playing Mega Man, like you're playing to beat the game, you know what I mean? Like when you're 9. Now when I play Mega Man, I know that something's going to distract me in like half an hour. Like I know I just don't have the block of time to beat the game. So I play like more reckless, and maybe that's part of it. But yeah, basically I can't get like even half as far as I could when I was a little kid.
Wow. I think it's also like a lot of those games you needed to essentially memorize the level and the timing and the thing. And I also don't have patience for that.
Yeah, so I'm comparing like myself, like having not played for 20 years, playing for the first time, versus like myself at the end of like having played for 6 months straight.
Right.
Yeah. That's not.
Also, there is a thing out there on the internet. People talk about our games are becoming easier, right? So you have saves and continuous save or walk away, or you can just checkpoint way too often or have too many lives. Or now like the common thing in first-person shooters is not to have to go collect health, but you get shot and like you just go hide behind a box for a few seconds and then your health is charged back up or whatever. So I mean, these things are making games easier. But.
I always feel like that was sort of like a cop out, because I think what that does is like when you have these things like a lot of checkpoints and saves, what it does is it makes you spend more time focusing on like the real problem, right? And less time like replaying. So for example, like Mario, we all had to play World 1-1 a million times, right? But if we had, a checkpoint every level, then we would spend more time on the harder levels, like getting the important skills, Yeah. So there's really like a exclamation, a point to be made either way. I guess at the end though, you don't have the satisfaction of I went through the whole game in one sitting, right? So.
Yeah, no, it's an interesting thing. So I didn't really have an amazing point there, but just I was thinking about this kids and games and whether my childhood playing games was good, too much, too little games. Yeah. What should it be now? And
I wonder, like, are we going to be those parents that like tell our kids to go play outside like our parents did? Because
I feel like you have to tough. At some level. Like you need to understand there's a world outside of games and computers and video. Like I think that's an important aspect. But on the other hand, there's some parents who don't let their kids have any computer time and game time. And I don't know, like I feel like it's such a part of society now, and right. Getting a job, especially if your child may show a predisposition to wanting to get into something technical or computer related, like understanding those skills are important and good to learn early and have time to practice.
If your child wants to listen to programming throwdown, you should let them. That's a general rule we've found.
Yes. So talking about games, new Kickstarter that was all the rage. I guess it's now a little bit of an old story, but it's okay. The Ouya.
Yeah.
Ouya.
This thing's pretty awesome. Basically, what they did is they took the Android OS and they created sort of an interface for the TV. So it runs Android, it connects up to your TV, I guess HDMI or something like that. And then it has these Bluetooth controllers that they look kind of like the Xbox controller, like they're kind of designed to fit well, and looks like it's going to have dual analog sticks and all that. And yeah, the idea is, you can play all these Android games in a TV setting, like, and their whole like mantra is bring gaming back to the living room, because the idea is, we haven't seen a new Xbox in a while. We haven't seen a new PlayStation. I think like a lot of these console companies, they don't really know what to do. They feel like things are sort of leaving the living room, and so much more money is to be made online, making these like casual games for your phone and things like that. So this is sort of an attempt to sort of create an open platform, when something that's never really existed in the console world, and bring gaming back to the living room. And it seems pretty cool.
Yeah, I like the idea of what they're trying to do. I wonder if they haven't bit off more than they can chew.
Yeah.
I mean, they seem like they have some sort of experience in the field, so that's good. But I do agree that, the Wii kind of tried to get there, right? Like this casual gaming thing for your TV. And in that way, I felt that it was successful. For me, the Wii comes out when I have a lot of people over to the house or something.
Same
I don't ever play it when I'm just like me, like I want to play something, because the graphics aren't very good. It's kind of silly to be sitting there moving around. I don't know if that's me. But I feel like this Ouya console could be like, it's like iPhone games, but on the TV and for your family or for when friends come over. Yeah. And it really could be that fun and exciting thing, especially if they, kind of embrace that, as opposed to saying we're going to be a gamer's game thing. Then maybe it'll be good. It could be. There's a lot of good games out there for even the mobile platforms.
Yeah, I think a couple of cool things, or a couple of things to note. One is, I think it'd be super cool if they somehow integrated the Ouya with your phones. So like, for example, like a simple example might be, it's some kind of multiplayer like RPG game, let's say, and you carry your character on your phone. And then
when you go to your friend's house.
Yeah, you're both playing together.
Oh, interesting. I didn't think about that. The classic one is, and I think this is the one, the new Wii U, is it, I guess? It's supposed to have tablets, and it's like you're playing, football. And instead of having the plays up on the screen, you have to hide what button you're pushing. So you have it on your screen, and so you can make the play or draw an audible or whatever. And the other person has no idea. Or you're playing like a board game, right? This is kind of cool. You're playing a board game, and the board is on the TV, but your pieces and your character are on your phone.
Yeah, that would be awesome.
So you're making selections. Yeah.
Yeah, so I think there's a ton of cool stuff. They could make it to where even a single-player game, let's say it was some game that had it was like an FPS, but there's like a strategy element to it. So like maybe when you're at work, like in your off time or whatever, you'd be on your phone like doing the strategy part. so that when you can come home, you can like fight the battle that you've been like preparing for. You know, something like there's just so much potential.
That's
there,
true.
right?
Or like the immersive style games, they try to do this for a while, where like you're at work and you, maybe it gets too much like Farmville, I guess, but you know, you have like a notification comes up that like, hey, you know, your person is fighting on the lines at home, you know, you need to like go in and drop into this mini game and help them out, or go into a little battle, you know, whatever, and then when you get home you can like wage the war or whatever. But
or maybe like your whole family is fighting the battle at the same time. Ooh. So like you might be playing the game and like your wife might be like on her phone at work and she gets a notification like, I don't know, play this mini game to help out.
No, maybe this is just starting to sound like too much like work than a game. I don't know. So that idea to me is very appealing, and having low cost open hardware is good. The thing that I skipped about, I guess, with the Ouya is they're trying to have their game store, right? And you go to them, but they're taking, as opposed to like an upfront fee to go with an Xbox and then a recurring licensing fee or whatever, they're just trying to make it kind of the same app store model, right? And then requiring everything to have at least some free to play element, which is great. But you know, I don't really want another closed place for games. Like I want a console that's like my PC, where I just download whatever I want, play whatever I want. If somebody wants to make an open source version, great. You know, I did that, and maybe you will support those kinds of people can bring free stuff and it not be a hassle or a problem for them. And I really hope that's true.
Well, I think that they said that all the games have to be free. Like the only money that could be spent is on in-app purchases.
Well, I think it's like it sounded like a demo, right? Like you get the first level and then an in-app purchase for all the rest of the levels.
Yeah, right.
So, okay, I mean, but what about somebody who doesn't want to pay anything? And I didn't read it that closely to know. But, like, what if you just wanted to release, like, hey, here's this crazy thing called Trivipedia, and I want to release it for you, and you just want to sell it for, you know, I don't want to sell
name
it
to it or something.
Yeah, like, will that be okay? And they've said, oh, we'll allow it to be rootable. Then the issue is always, once you root it, there's problems with subverting the purchasing mechanisms in the store, so then they try to probably not let you be in the store if you have it rooted. I don't know. We'll see. It'll be interesting. So I haven't backed it. Have you?
No, not yet.
No.
But one more thing before I talk about it is one thing they haven't addressed is the fact that all of these games so far, like all the ones they list, they were all designed for a touchscreen. They weren't really designed for.
So the controllers have a touch screen on them, like a touch-sensitive mouse pad thing. Yeah.
See, how come they don't have any?
So that if you look there in the middle between the joysticks or whatever, between the analog sticks, there's like a little pad, and you're supposed to. But there's a lot of people are questioning, like, how are they going to do this? So it's essentially a phone type motherboard in the box, you know, and then these controllers are supposedly going to be nice peripherals. So are they even going to be able to make, like, is the price too low? $100. I mean, this is way lower than any other, you know, I mean, Microsoft,
that's pretty sophisticated.
Xbox, I guess, is like $140 maybe, or $200 on the low end or something like that. I mean, it's up there, and that's like they've sold, you know, loads and loads and huge economies of scale to get down to that price. So it'll be interesting to see what Ouya tries to sell the, you know, once it goes commercial, like once they're selling it on their website or whatever, what it'll sell for. Will they be able to keep the $99 price point? If so, it might be good traction. And then how many people need to be on the Ouya for it to be an ecosystem worthy of targeting?
Yeah,
so like, you're a developer for iPhone right now. Like, how many people? You're not going to convert everybody. So how many people need to be on the platform for you to spend, you know, however much time of your own money to port it to their system?
Yeah, exactly. Yeah, it makes sense. Yeah, you really have to get that critical mass to get the developers online and everything.
Yeah, but they've raised a ton of money, like $5 million, right?
It's insane. Crazy. $5.4 million.
Yeah. You and I need to come up with a video game console.
we need to make this app for this console.
There you go, a game for the Ouya.
Yeah, the you know, you have to do something all day game.
Oh, the one we're talking about. Yeah, maybe we will. All right. In all that spare time that we have.
Yeah, exactly. Yeah. So this next article is C and or C++ worth it? And I thought this was a really fascinating article. You know, just to get to the meat of the article, they say no, it's not worth it for almost everything. And they show Java as an example. But yeah, I mean, one thing that I noticed the article doesn't talk about is memory, you know, layout. So the example that the article gave is, you know, they ran through a loop, ran through an array, and then added the previous element of the array to the current one. So it was a simple like array add operation. But I mean, where a language like C or C++ really shines is in laying out this memory model either beforehand or laying out a memory model that's very efficient, and then working within that model. And so that I feel like the article is sort of wasn't very holistic, but it's still a really interesting read. It's cool that Java actually outperforms like C++ in many different in this test case in many different compilers and things like that.
That is cool. We'll talk a little bit more about Java performance in our section to come. But I always see these, and I kind of always a little doubtful because you really need a whole benchmark suite of really orthogonal tests. Because we can probably find any number of things at which any language is faster than any other language, right? Like if you have the whole search space of potential algorithms or simple programs, you just try one until it beats the language you're trying to beat, and then you go, look, I found it, here. Yep. And it's like, you can spend time optimizing for any one thing, but what I want to know is like, on average, if I just throw a random problem, or I know this is my typical domain set, how does one language perform against another?
Yeah, totally.
And this, I don't know, this article is actually, pretty short. I mean, it is interesting that the typical Java slower than C++ thing at this low-level task doesn't apply in this situation.
Yeah, I mean, one thing to sort of take away is that, these arguments of, Java is really slow, like, you can't do this in Java because Java is slow. Like, that argument isn't true, right? I mean, worst case, let's say Java is 2 or 4x slower. For almost any application, that would be fine. And a lot of times you hear people say, I can't use Java, it's too slow, or I have to do this in C, and that doesn't really, for almost any application, that doesn't make sense. But at the same time, this very simple example also doesn't prove anything either. So
it's interesting, and it's always interesting to read the comments on these articles and see all the crazy optimizations people suggest, and you're crazy, go away, and all the way to very well written. Actually, if you wanted this suits Java better to suit C++ better, you would do it like this, and nuances of various things. It is an intriguing read, and sometimes you do learn some really nifty tricks that the gurus in any language tend to know about their language. And what is it, Donald Knuth quote in The Art of Programming, right, that early optimization is the root of all evil. I'm summarizing
premature optimization.
There we go. Okay. And
I found out sorry to interject, I found out Donald Knuth and I go to the same optometrist.
What?
Yeah.
Can I switch optometrists?
You could totally go to this optometrist.
Can you ask for an appointment that's, you have to have your eyes dilated and you have to wait in the waiting room for a while?
Yeah.
Can I ask for my appointment waiting to be right when he's getting his eyes dilated so that I can talk to him?
You could, except now these guys are on this, what is it? Optiplex or something? The thing where they take that image of your eye.
Man.
Yes, you can't do that. But maybe you could get it to where you find out when his appointment is, and then you just show up, and you're in
creepy.
The waiting room.
I think I'll get a restraining order. So okay, we got a little off topic, but yes. So that is cool. Congratulations.
Yeah, you should totally go to this optometrist.
Okay.
He's a pretty cool guy too. So
okay, I'll have to get that from you later.
Yeah.
So the next article is I thought this was very interesting. Engineering jellyfish. So some researchers kind of made jellyfish out of a combination of plastic, and they grew some muscle on top of it and rat parts. And so I think it's interesting. As far as what they managed to accomplish, did they create life? Well, I mean, they used some existing cells, so no. And also as they tuned everything to behave to the materials they had at hand. They knew these cells act this way in this solution, so then they kind of engineered the whole thing to do it. But it is still kind of cool that they managed to make this star-shaped device which flexes and kind of, if you ever seen a jellyfish move, kind of balloon and squeeze out the water to move forward, which isn't efficient. It isn't the most supreme way of moving. It isn't really fast, but it's kind of cool that they're able to kind of get these things to move in a way that really resembles things. And I always think that's interesting, this clashing of, and this one doesn't have a lot of, it doesn't have a microprocessor or anything in it. But there was another article recently about the people who programmed a robotic fish, which got accepted by the School of Fish or whatever.
Oh, really?
And so they thought it, and it was able to lead it at one point.
Wow, that's awesome.
So I think this is kind of cool as we kind of learn more and more about animals and what we can take from the animal kingdom and say like, oh, this is even from you always see those videos of people trying to fly like birds and putting wings on their arms and trying to do this kind of stuff. And even to today, we're people will look back on this jellyfish and say the same kind, well, maybe not this jellyfish, but these kinds of endeavors, right? Like, and kind of say the same thing. Oh, these people are trying to.
Yeah, I think that like if there's some domains where even just the simplest animal is so much better than our most sophisticated computers, right? I mean, look at like image recognition or whatever. A dog is just way better than a supercomputer, right? And so all of these attempts to sort of like integrate, what we know of computing and processing with, the animal world and sort of how the brain works is interesting, because as we sort of bridge that gap, I think we'll learn a lot on both fronts. We'll learn more about neuroscience, and we'll also learn more about computation.
And I guess I find intriguing this, I don't know, what is it, cyborg type stuff. You see these things where people put microcontrollers on the back of cockroaches and control them. And people insert brain inserts, right? I mean, all these kinds of things are so cool. Is being able to bring stuff that much closer. Originally computers were in a giant room and you couldn't go with you. Then now everybody carries around very powerful computers in their pocket, and then maybe soon on their glasses. So I mean, always getting closer and closer and closer, and those things are just kind of exciting and cool, and the rate at which we're progressing is just kind of astonishing. Yeah.
I mean, I think that it would still be a long time before we have, what's it called, strong AI. I think that's the term. So strong AI means basically that it would pass the Turing test for day-to-day activities. Like that's like strong AI. So I think we're still really far from that, right? But I think that means that it's just a completely open area. And if you can make progress, there's just so many different fronts in which you can make progress. Like vision is probably the one that's been explored the most. But think about even just like muscle mechanics, right? Like your muscles are just a bunch of thin fibers that are put together, but yet a robot has just a single joint.
Like a motor,
and so like why isn't a robot knee more like a human knee, where it's like hundreds of these tendons that move together? Why is it just a hinge joint? And so I mean, like, I think all of these are interesting questions, and they're all, maybe this jellyfish makeup is a step in that direction, right?
Yeah, so. I mean, that is true. Even if you had really good AI today, I mean, we still don't have like a vessel to put it in that would allow it to really act like a human. It would be obvious. Exactly. Like they don't move. They're not capable. Bipedal robots of today aren't really capable of moving in a way that fools you into thinking it's human. And even if they're typically either tethered or have a short battery life or aren't a full torso. Just all these limitations. So I wonder if it'll end up being one of those things like we talk about processing speed has outstripped kind of batteries. That our batteries just haven't been able to keep up with how much power we need to be able to run mobile devices. The growths just don't match. Mm-hmm. And I wonder if it'll be the same thing, that we'll look back and see how we've gotten better and better at having machines that can do more, but then like just nothing to put them in.
Yeah, exactly.
In other words, everybody can't go into computer science.
Yeah, we need some of you mechanical engineers and biologists and neuroscientists. We need you guys too. So.
Yep. Well, I think it's time for Tool of the BiWeek.
Tool of the BiWeek. All right, my tool is it's a set of 3 tools.
Wait, that's cheating.
It's totally cheating.
Now you're just making it so you can look better than me.
But they're all basically the same. And I'll talk about all 3 of them briefly. So I'll talk about the Windows ones first. Basically, all 3 of these tools have the same purpose, which is to bring the awesomeness of like Unix and like all the cool packages and the GNU packages that people have made and bring those over into other operating systems. So Cygwin, which actually I think is short for like Cygnus Windows, which is like Cygnus is the company that I think is now bankrupt or something, but they made this, is actually what's called POSIX. So a little bit of history. Unix runs on top of this thing called POSIX, which is, or maybe POSIX runs on Unix. I don't quite know. This all happened way before either of us were born. But essentially, POSIX is the thing that implements a lot of the functionality of Unix, like fork, which is a function which takes your process and splits it into 2 processes. while keeping all the variables in both processes, so it like makes a copy of it. So all these like very primitive functions that comprise like the Unix layer right above the operating system, right above the kernel. So that POSIX, someone went ahead and implemented that by using Windows calls. So when you call fork, Cygwin turns that into like a Unix, or sorry, like a Windows, like the create thread function, and then copies over all the variables manually or something like that. So they implemented all the POSIX routines in Windows. And then once they did that, now for programs that are built on Unix, like GTK, for example, they will just compile on Cygwin because they don't know any better. The functions just do what they're supposed to. And to these higher level programs, it just works.
Which is the beauty of something like POSIX. If you kind of really restrict, here's in essence kind of an API you're programming against.
Yep.
How strong that can really be.
Yeah, totally. So Cygwin is awesome, and there is one problem with Cygwin, which is, you have this POSIX code, and it's wrapped in what's called the Cygwin1.dll. And as I mentioned, all of the code calls functions in this wrapper, in this intermediary layer. So let's say I was to make a program with Cygwin, like Jason's program, and I wanted to give it to Patrick. I also have to give him the Cygwin1.dll, which that doesn't sound like that big a deal, but there's actually a license restriction. The Cygwin1.dll is GPL. So which means if I was to give Patrick Jason's program, I also have to give him the source code. And so that can cause issues, depending on your environment and things like that.
The other issue that I've run into before with Cygwin is that although it's great to cross-compile and it works really well, like it's an amazing tool and it helps a lot of things, is that you can end up with trickiness. You think you're running in Linux sometimes. And so if a program is doing something which is normally takes, 10 milliseconds in Linux, but it might, because of all the extra work that has to be done in Windows to simulate, it might take 10 seconds or something crazy.
Yep.
You can end up with programs that are just completely unusable or just take a really long time. Because like for instance, fork in Linux is a completely different kind of operation than creating a new process in Windows.
Yep. Yeah, you're totally right. So in general, so let me get to the alternative to Cygwin, which is called MinGW, which I think is minimalist GNU for Windows. And MinGW is similar, but it actually works on the compiler level. So what that means is, I write my code, I have access to all these cool POSIX functions, but then what they do is at compile time, they dump it all together into an executable that completely is self-sufficient. So you don't need the Cygwin DLL. It's not, MinGW isn't GPL, so you're okay there. And in general, the executables are faster. So the bad thing about MinGW is it doesn't have this package manager. Like with Cygwin, you could just run the Cygwin package manager and say, I want GTK, and it'll do everything. A couple of clicks, and now you have GTK. MinGW is more of a compiler, so it's not really meant for that kind of thing. So in general, use Cygwin when you want to run Unix programs, and use MinGW when you want to make programs from the Unix libraries.
Yeah, that are kind of compatible. Yeah, that's the way I kind of use it.
Yes. So that's for Windows. Now, for Mac people, don't feel left out. You can totally use, GNU programs. You can totally use your GNU Cache and GNU Chess and GNU Go and all those cool things, and Inkscape and GIMP and whatever, by using Macports. And so Macports is how would you describe Macports?
So I think it's a little bit of a fundamentally different thing than what happens on Windows, because Windows isn't really based at all on a Linux type POSIX environment, whereas OS X kind of is. Yep. So OS X is just kind of providing the right kind of compliant libraries to kind of get at, this is my understanding, I'm probably messing this up,
no,
but
to
get at the understanding that underlies, like here's how to do the thing you would do in Linux, but on OS X or...
Yeah, I think that's exactly right. So Macports is basically just changes to like build systems and things like that, which are sort of Mac specific. And it sort of takes into account the fact that like some things already exist on Mac because it's also a POSIX compliant system, but then some other things don't exist or have to be rebuilt or something like that.
And I guess the other thing is, making sure that the right libraries are there.
Yeah.
Because it doesn't, it doesn't natively know how, a Mac doesn't natively know how to get all of the right libraries associated with it. So you kind of need a way to say, hey, I need to go grab all these extra libraries that didn't ship with my computer.
Yeah, exactly. Yeah. So yeah, these are great. If you use Windows, you should be using Cygwin. If you're a Mac guy, definitely check out Macports. If nothing else, it's fun to use these programs and just browse through all the packages, because there could be like some really interesting tools that you've never heard of, or maybe new programming languages that you want to try that are already there, that you just a couple of clicks and you can get them on your computer. So.
And I should probably correct myself before we get lots of not happy email about
Okay.
saying OS X has Linux underneath. And this is where I'll show it's really BSD, I think.
Oh, really?
So I think OS X has BSD underneath it.
Oh, okay.
And even then there's some other
Yeah,
swirly
who
stuff.
knows?
So please just anything that was said in the last that wasn't quite right, just please forgive us, or forgive me anyways.
Wow, that's our first mistake ever. Man, it's like that's a milestone, mistake number 1.
Yeah, number 1.
Yeah.
Uh-huh.
So
So my tool of the BiWeek is far less technical than that. So uShare. And I have a Google TV, a Logitech review at home, and I had some movie files on my computer, and I wanted to stream from one to the other because my computer is hooked up to my small monitor in one room, and I have a nice TV in the other room, and the Google TV is hooked up to that. And of course, Google TV works great for playing Netflix and other stuff. And they have, and this is true of many now, actually TVs themselves, and things like we talked about last week about Xbox Media Center, even running on like an Apple TV,
Yep.
that you have the ability to stream from a DLNA server. And so I tried to get various DLNA servers set up on my my computer, and I got some to work, but most of them seem to want to go into GUI mode, require lots of setup. But I was able to get uShare installed so that I could kind of configure it and manage it over just SSH, so that I
Nice.
didn't have to keep going into this computer that wasn't always plugged into a monitor. And so now it worked great, like just right out of the box. I mean, it doesn't do a lot of the DLNA servers try to index your files and say like, oh, here's movies with actor. I don't know an actor. Give me an actor name.
Tom Hanks.
Tom Hanks. Tom Hanks. Here's all the movies with Tom Hanks in them, and like, let me go fetch all this extra
That
data.
sounds cool, though.
That would be cool if it worked.
Okay.
And then if it doesn't work, it kind of like seems like most of them just default into kind of like giving up or whatever. And
yeah.
it was like a mess. So I just wanted I have it fairly well structured in a file folder structure that I wanted. And uShare has, I think, this other option to do this indexing and do awesomeness, but I didn't really want that. So I just turned it off and just please just give me, so when I go into my Google TV, I can navigate to the folders and then just select the video file I want, and then it does the transcoding for me. So because Google TV, only does a very limited set of codecs, the uShare knows how to convert it using, I think they use FFmpeg by default, convert it over for me so that it just plays. And then it's like, this is lovely. And it starts up really fast and goes smoothly. And I haven't had any issues or any files I came across yet that wouldn't play. And so that made me very happy. So that's why they get a recommendation from me. That's uShare, and we have a link in our show notes.
So just so I understand, because my media setup thing is a disaster. I need you to come over. I need to hire
this
you as
sounds
a
like a time
consultant. But so I have a desktop which has a bunch of movies on it in one room. And then I have a laptop connected to a monitor in the other room. And right now I just do this painful, I'll copy the files over and then run them. Or I'll have like an NFS, but it doesn't quite work right because it's not like a true media server. So there's all sorts of latency and sometimes the video stutters. So you're saying I can install this on the desktop in the living room, which doesn't have anything attached to it.
Right.
And then the laptop, what would I install on the laptop?
So on the laptop, if there's all sorts of what you want is a UPnP or a DLNA client, right? So there's all sorts of, I think VLC will even do this, right? And connect up to it. And the nice thing is if you have a laptop, you actually shouldn't need to do any transcoding because your computer can play everything. Right. So it'll know how to stream it. But the DLNA servers, and I believe uShare will do this too, it will also detect your link speed. So it knows even if you understand the codec, if the rate is too high, it'll downcode it for you so that it can stream reliably across the network.
This is amazing.
Right? I mean, this is stuff that's done all the time for YouTube videos, for Netflix. I mean, this technology is out there, and it's just, sometimes it's a little complicated to get set up. And so I kind of ended up taking the shotgun approach and installing 5 different, UPnP servers and seeing which one would just work nice with my device.
And then you use VLC as the
client? So on mine, I have a Google TV. So Google TV has like a specific, like, here's the program you run. Or if you have a TV or an Xbox or a PlayStation 3, they all have like, these are the program you go run and select the file you want to play, and then it'll stream it for you. But on a laptop, there's lots of them. So like if you're running Windows, like Windows Media Center will do it, or just Windows Movie Player, Windows, whatever the Windows movie player thing is. Or like I said, like I think VLC will do it. There's also Xbox Media Center, which we talked about last week, is UPnP client as well, and will give you the nice what they call 10-foot display. So the ones with the big words and not the normal file menus, so you can navigate with large categories and select it on your remote, and then be able to play it that way.
Nice. That is awesome. I'll have to check that out.
So if it works, you'll have to report back and let us know.
Yeah, next week. I'll try it this week.
Or you can email me and say, oh, it's not working. What happened?
So 2 weeks from now, either we won't have a podcast because Patrick hates me, or we'll be talking about how I got this media center set up.
Anyway, check it out. That's uShare.
Yeah, it looks awesome. Yeah, I'll definitely do that. And folks at home should too.
Time for Java.
This is like... trying to swing a sledgehammer. I mean, we probably won't be able to cover.
Yeah, I think we already agree. We're going to call this like Java Part 0.0.1.
Java Micro Edition.
So this is going to be an introduction. We're not going to try to cover everything, and we know we'll come back and revisit some more of these things later. Yeah. So Java kind of has an interesting history. I mean, everything has an interesting history, I guess, if history is interesting to you.
The interesting thing about Java is that the history was, like, when we were sort of learning, when we were learning as much as possible about computer science, like when we were learning more per month than ever, Java was like the language.
That's a good way to put it. Yeah, it was like right in the sweet spot of, for me, like, right when I was kind of getting to college, Java had just come out of its infancy.
Yep.
And it was like, right when it first came out, I didn't really know what was going on. Like, I didn't know. I heard about it, but then like as I began to get into late high school and college, like, I began to see like people wanting to use Java and think about Java and talk about Java.
Yep.
It was the hotness.
Yeah, that's right, the hotness.
So their slogan, which I think, is still kind of one of the best strong points, which is amazing that we kind of take it for granted that somebody can set out to do something and then actually do it. So Java had this write once, run anywhere.
Yep.
That was like their slogan or whatever. And, without getting into too much debate, it took them a while. But I think today, regardless of everything, if you just ignore that, look at that motto from 1995 and then now like 2012, and you say like, hey, Java, where's it running? And Java runs on all sorts of platforms and devices. And, I don't know how much the write once part comes into there, but they really are, making it so that it is so much more pervasive than a lot of other languages ever reach.
Yeah, totally. Yeah, I mean, think about all the pain that goes into like deploying an app, I mean, you have to deal with, first you have to build it for every architecture. Then you have to deal with all these like 32-bit, 64-bit issues, if it's big Indian, little Indian. So not only do you have to build it for these different architectures, but sometimes you have to change the code depending on which one. Like, God forbid you try to like, mem copy a structure straight to a file or something, because that'll never port over, right? So there's all these disasters. And then, you finally get it to where the code is okay and the code runs the same on all these machines. Now you have to deal with, this person's missing this library that you expected them to have installed. So now you have to carry over like a virtual machine, like VirtualBox or something, that runs a completely bare bones Windows, and run your program there and make sure that you don't have some DLL that you didn't realize you had that no one else has, right? So you have all this drama. With Java, you can, using Eclipse or NetBeans or any of these IDEs, these tools we'll talk about later, you can just click on your Java code and say, give me a runnable jar, which is, was it Java Archive or something?
Sounds good. I'll look it up.
You just say, hey, give me a package of like take this code and make it run on any machine I want. And it will do it. And you'll end up with this one file. You can give it to your friend as long as he has Java installed, which now the install base is like extremely high. He can just double click the file you gave him and it'll work. And you're just bypassing all of the things that I mentioned before. So, I mean, this is huge. Now we take it for granted, but at the time this was just incredible that you could do something like this.
Yeah, I feel like there's a lot of legacy that goes into Java. So, and whenever we talk about it, ultimately you kind of talk about it from one aspect. There's like the individual programmer, there's like the enterprise team, there's the, person learning to program, there's all these different things. And so, kind of have to take one view at a time. But, a lot of early experiences of Java kind of maybe had some missteps. Or people have bad memories or bad taste, or somebody who's really good at C++. Java looks so close to C++ in so many ways that you're kind of tempted to just do things the same old way.
Yeah,
and we talk about that a lot on this, this podcast, that when you use one language and then go to another, you can bring a lot of really interesting things. But if you just try to shoehorn one to the other, like, here's my C++ code, I want to line for line just like copy it into Java. Well, you can't expect that it's going to be like the greatest ever, because that's not, you're not using it the way it's meant to be used.
Yeah, totally.
So, and then, one really cool feature of Java was this notion of applets. So, Java in 1995, it's coming out, and this is like right around the time, or at least I remember, like the internet was really coming into like its own and really starting to get a hold and become a serious place that people did business on. And it was really becoming what kind of it is today. And so these applets were programs you could run in your browser. Instead of having to even send your friend a jar file, you could just host it on a server and he could just go to this page and have the applet run.
Yeah, I mean, and this is just mind-blowing, right? I mean, so this is before Flash, before any of that. So, I mean, basically you had either HTML or you had applets. I mean, that was pretty much it. I mean, you could do some clever things with like CSS 1.0 or whatever, so you could have like the font changing. There was JavaScript.
Blink tag.
Yeah, you could do the blink tag. There was like some basic things you could do with JavaScript, but it was too slow. I mean, JavaScript is like 30x faster than it was back then, so you couldn't really do anything fancy. And then applets came out, and it was like, oh my god, I can do whatever I want. Like I can just draw pixels to the screen if I want on someone's website. And that just like blew people's mind. One of the most popular applets, remember, it was like you would give it some text and it would create this like reflection, but the reflection was shaking as if it was like a pool.
I don't think I've ever seen this.
Yeah, that was like all these websites had this applet where it's just like the name of the website and then the name like inverted.
It was kind of like, I always felt like I had slow internet for a long time until I kind of went to college. And so like whenever I went to a page with Java, I knew it because it would just like take that much longer, to load. But I think the other interesting thing that Java really addressed, and this might be me misremembering in nostalgia, but because Java was from the start kind of heading towards the internet and had this applets, and they really had to address security, like how do we really make things secure, since the browser is going to let somebody run arbitrary code just kind of like without permissions. They don't even have to download something. You just go to a website and all of a sudden code's kind of running.
Yep.
And they've kind of iterated through that and done some stuff, but really thinking about how do we have a good sense of security and how do we balance that with needing to access a person's computer but guarantee that those things we're doing are safe or allowed or okay.
Yeah, one interesting like side note. So SGI did Silicon Graphics Incorporated did like a bunch of like crazy pioneering graphics research. Like when the Nintendo 64, when that came out, there was this weird thing. It wasn't quite a triangle. It was like a scan line, like weird polygon thing, and they were using that for doing like 3D rendering, and it was like totally kind of crazy off the wall. And then they tried that, they refined it, then they switched to the polygon model. They did all this pioneering research, and then they died, and it's sort of like this huge investment, and the company dies, or they got bought or something. And I feel kind of bad because the same thing happened to Sun. It's like they made Java, they did all this cutting edge pioneering, like groundbreaking stuff, and then they got bought like almost immediately. Like it's
it wasn't like, exactly immediately. I mean,
when did they get bought?
It was fairly recently, right? So I mean, I think they had a good 10 years, 15 years or something.
Oh, was it really that long?
Yeah, and Sun did a lot of other stuff as well, right? Like I think they might have existed before Java doing other things.
Really?
We should have done I guess more research into Sun itself. But yeah, because they used to make like server hardware and stuff as well.
Well, yeah,
was that before or after Java? I don't.
Solaris has been out forever, right?
So yeah.
But even like SGI has been out forever too. But like the companies like usually like it seems like they come up with awesome stuff and then like a few years later. I don't know why that is.
Maybe, but sometimes that's a good thing, right? Like sometimes it means they did really well and somebody was willing to pay a lot of money for them.
Yeah, that's a good point.
So that can happen. But yeah, so I mean, Java really did was the first kind of mainstream language that addressed a lot of new paradigms, as it were. It kind of came out, and it's like C++ had done the object-oriented thing, so like now Java's going to do it, and Java's going to do it kind of in its own way, and really embrace this, object-oriented model and take it kind of to a new level, and and really try to meet the needs of a lot of people. I mean, there are programming languages that did object-oriented arguably better, in a different way, and a lot of them got acceptance in niche ways and kind of specific, but to make a mainstream acceptable programming language requires some compromises to try to meet everything that you are trying to do. Yep. And it's kind of amazing that Java was able to do that as well as it did.
Yeah, totally. And the cool thing about Java is they kept it very close to C++ from a syntactic point of view. But so there's like, you could think of it as a lower barrier of entry because a lot of the code looked the same. But they made sure it was sort of pure. Like C++, it's kind of clear that the object-oriented was built on top, right? And that C++ was sort of built on top of C. And it's sort of really evident. Like, for example, the way callbacks are implemented in C++. Like, imagine if even member function pointers. Like, if you want to have a function pointer to a method inside of a class in C++. It's like, that stuff's a disaster, right? Like, trying to do that is just a nightmare, like bang your head against the wall. And it's because it's sort of, C++ was sort of trying to do the whole classes thing, but still interact completely transparently with C. And so by Java sort of separating itself from all that and saying, we're not going to have these native arrays and all these things and, just functions hanging out global functions. We're not going to do that. By making these restrictions and by making a brand new language, they're sort of able to make it a lot cleaner.
Java also sticks out in my mind as coming out with updates. So I guess because C++ was kind of written and it wasn't really a company that kind of owned it, right? Like, this is our thing, we're making it. It was good and bad. So Java came out, Sun owned it. They had made the virtual machines that the code. So we should talk about this a little. So in Java, the code compiles to, like Jason was talking, like a jar to these class files, and these things are compiled against not your hardware, but against the Java virtual machine.
Right.
The Java virtual machine is written to basically run on your hardware and run the Java program on that program on your hardware.
Yeah, so all those things I talked about before, like the 32, 64-bit and the big Indian, little Indian, they dealt with that when they made the virtual machine. And so now you don't have to deal with that because you're sitting on top of an abstraction.
And so when they kind of made all of that, right? So they owned the virtual machine in a way. They, kind of defined the language. They were able to make kind of updates, add features. And if you look at Java today, there's a lot of, if you try to just compile a Java code written today against an early Java, I don't think it'll work.
Yeah,
so much stuff has changed. And just even basic assumptions have changed over time, and things have gotten optimized and better, and adding new features and kind of working on the rough edges. And I feel like they were able to do that because they could, because they kind of own the stack in a way. But that didn't stop. I mean, in the licensing thing, we're not lawyers, so we're not going to really talk about it because it gets really complicated and gets into it. But I mean, even from fairly early on, there were people who wrote other virtual machines. So Java compiled to this bytecode, but if you could write a program that would interpret that bytecode and do stuff, go ahead.
Yeah, I saw something interesting the other day where someone wrote an LLVM interpreter for bytecode or something like that. Or actually, it was it took in bytecode and it output C code. So it's this Java to C compiler. It was kind of crazy.
So, but I mean, the bytecode is essentially a machine code, assembly code for a known virtual machine that isn't a real PC.
Yep.
And so that kind of concept in doing that's really intriguing, and people could do that. So in theory, if you think you can write a faster virtual machine than Java for a specific instance for your use case, you could do that. Yep. And again, ignoring all of the licensing and problems and copyright, but I mean, this is what you hear about when people say Android runs on Java. So on your phone, when you run an Android program on an Android phone, that seems redundant. So it's not running on a Sun virtual machine. It's running on one that Google wrote that to the program kind of looks the same.
Right. Yeah, exactly.
And they're able to, do that and make it because of some of the decisions that Sun made. And also, I mean, Sun did open source Java in 2006. So even though they own it and they can still continue to make updates, it gets so subtle. I still don't understand exactly the problems. Like, a lot of people are unhappy with the way they open sourced it, but other people are saying, like, this is a groundbreaking step that they did open source it and make it available for other people to use and modify and build on top of. But needless to say, they made an effort. They did some open sourcing. They revealed a lot of stuff. Yep. People can come in and make changes and use it and kind of change it for their own. And that's kind of an interesting thing, and it's kind of cool. And Oracle bought Sun, who was creating Java, and some things seem to have changed in the way that they will agree or let people do. But ignoring that, I mean, I feel like Java has really changed a lot from the way I remember it, like what it used to be used for and where it went, and then what it is used for today. Yeah, and I guess definitely. That speaks to like the flexibility. It hasn't fallen by the wayside.
Yep, and I think that a lot of the research in like so one thing Java has, and we'll kind of touch on different things as we talk about it and keep the dialogue going, is a just-in-time compiler. And so this is a little bit complicated, but basically the way it works is, Java will look ahead. So the virtual machine is sitting there executing your code, and it's doing like if statements and going to different places.
It's executing the already semi-compiled version of your code.
Right.
The version in Java assembly.
Yeah.
Java
the bytecode. Yeah. So it's executing the bytecode, and it can look ahead and say, hey, you don't have an if statement coming up for a while. Like the next 30 instructions, they're guaranteed to run. Let's say the next 1,000 instructions before you get to an if or a branch. So let's see if we could do something clever. Like maybe these 30 instructions, they're all adds, and they're all around the same place in memory, so we can send it to what's called a SIMD, single instruction multiple data. We can send it to a SIMD processor. All 30 of these instructions can go to a processor that can do it all in one step. And so Java could do all these like really clever things.
And do that at runtime, based on the hardware it's running on.
Yeah, exactly, and do it like right a little bit ahead of like just in time. So just a little bit ahead of your program. So a lot of that research came about because the virtual machine was open source and people could hack it and do all sorts of interesting things. University students could go through and make all sorts of crazy optimizations and do a lot of experimenting. And Java has always been really synonymous with academia since the beginning.
Yeah, I mean, when I was in college, that was the de facto language of algorithms and data structures. Those classes, that's what we learned. We learned in Java. And then it seems like today they've backed off a little, some of the universities, to acknowledging that C++ still has a place, and there are a lot of companies still using it, and so teaching more C++. But the only course I had where you needed to know C or C++ was operating systems.
Yeah, I was the same way.
And even in operating systems, we still wrote some Java for a lot of the multi-threading example stuff. But for like a lot of the very, very low-level stuff, we had to write C, which was many people's first time of ever using C.
Yeah, that's a scary experience. Yeah. I remember the first time I saw in C, somebody casted he had a character array and he wanted to put a struct in the array because the character array is just representing a block of memory, and he casted the character array to like a struct pointer, and I was like, you can't do that. I was like, what's going on here, And so it's because Java is so much more strict, But from its strictness, I think, is sort of an elegance. I actually kind of really like that part of it. And one of the things which, I guess we'll get to later is Java is really strict about you doing exceptions and making sure things are the right type and things like that. And I feel like that for people who are new to programming, that sort of builds the right habits, So I still feel like Java is a good language to teach like at the university level.
Yeah, I agree. Yeah. I agree. It's kind of interesting to see because I learned C++ first, and then did most of my learning in Java, like at the university, but still, like I came into it with thinking about things in terms of pointers and memory layout and the kinds of things that you get drilled into you in C++. Because if you mess them up, you have to learn them early, and if you mess them up, the end results are really painful. So this kind of memory management versus comparing that to somebody who learned Java from the start and then tried to write in C++ and really struggling with pointers and, pointer indirection and, so it's kind of, there's pros and cons to both, because I do things in Java sometimes. There's you don't really need to do that because it handles everybody, but it's because I'm used to I need to do it this way because else my C++ program is going to blow up.
Yeah, exactly.
So even to this day, I carry forward some of the things. So it's interesting to talk about what language you should learn on that'll be easy for you, help you get through the most important and interesting parts, and then leave you set up for the best place for your future.
Yeah, I mean, a professor at my old university was asking me the other day if he should teach Java or Python to new students. And I still felt like Java is the way to go, because with Python you have sort of a lot more freedom, but when you're new, a lot of that freedom you can use to sort of make bad code. So with Java, it sort of forces you to follow a certain structure, and even if the structure, depending on what program you're writing, isn't good, let's say you're writing some kind of control loop or some kind of thing to generate reports, maybe Python would be the way to go, because you want to constantly be changing it, right? But still, to write it in Java and follow a certain framework can sort of give you the discipline you need to then go to other languages and not make a complete mess of it, except Perl. You'll always make a mess if you're writing Perl.
Yeah, it is true. Sometimes that rigor does, it's you can always write the class and talk about hey, how am I going to define this class and what are the interfaces going to be, and writing in something like Java or even C++ will force you into that, versus Python, you more get into the idea of just scripting. I'm just going to start writing a script to do this. And then, wait, I actually do need an object. Well, let me go. And it's kind of growing up in school, you always told you got to write your outline before you write your paper. And I feel I always did terrible at that. I always just wrote the paper and then wrote my outline based on what the paper was. But I do appreciate what they were trying to get into me and what I should have done and how it would have been so much better to sit down and think about stuff. And so sometimes object-oriented stuff does help with that, kind of giving a structure and an outline to your code.
Yeah, totally.
So some of the features that Java has, we talked about some of them already, but generics. So what is the idea of a generic? That sounds like a really bland topic.
Yeah, generics is that's a tough one to explain, but I'll give it my best shot.
That's why I asked you.
Oh, nice. It's totally awesome. So first, I guess the best way to explain generics is to give a use case, right?
Okay, let's go.
Let's say you had you wanted to create a list. So not you want a list in your program, but you actually want to create the concept of a list. You want to make a list class, right? So you don't want to have a list of integers. You want to have my class int list, and then under the hood it could be an array of integers that resizes or something like that, and then have another class called double list and a float list and things like that. What you really want is, as we talked about in the C++ podcast, you want basically templates. So you want to say, this is my list of type E, whatever E is. And then later on you want to say, okay, I want a list of ints. I want a list of, doubles. I want a list of floats. And you want
custom classes, a list of custom classes.
Yeah, a list of JSON objects or whatever. And you want the system to be able to understand what you mean. So generics are different than templates. But generics in the end give you the same end goal.
It's trying to get at the same thing, but doing it in a different way.
Right. So to explain the differences, in the case of templates, what the C++ compiler will do is, if you say, I want a list of doubles, the compiler will say, have you ever asked for a list of doubles before? Oh, you haven't? Okay. Let's take all the list code, which is list of E, which is where E is my template. Let's make a copy of this code, and everywhere I see E, I'm going to replace it with double, with literally just a find replace on that copy of the code. And then I'm going to use that reference. So you actually have duplicate copies of the code, one for each type that you're using in the case of C++. Now in the case of Java with the generic, it actually works kind of differently. So instead of being that sort of low level, it will still have the notion of E all the way through. But when you go to create a list of, let's say, doubles, the compiler knows that this specific list, if you say list double Patrick list, Patrick list push 1.0 or something like that. So it knows that Patrick list is a double list and it's not an int list, but it still only has one copy of the code. So this is kind of like, it seems like it's like really pedantic, like it's sort of a nuance, but the end result is that you pay a performance hit. So generics are not as fast as templates. Like in C++, you could use a template and it's like universally better. But in Java, in the case of generics, you are paying like a little bit of an overhead, price there. So
that was a good summary. It is one of those things that is subtle, and what exactly you're allowed to do and not allowed to do at compile time versus runtime when you instantiate an object. It gets very subtle and the differences. But I think you summed it up. In the end, it tries to get at the same goal.
Yeah.
How do I write code that applies to many different kinds of objects?
Yeah. The only other subtle difference between generics and templates, with templates you can put anything. Like you could have a template because it's just going to do a find replace, right? You could have a template and then template put 1. So like you could have, for example, let's say you had a class called array. Actually, Boost has this class called array. And the template parameters, one is the type, so you can put int, float, whatever. And the second template parameter is literally a number. So you can say like boost array, this is in C++. You can say boost array bracket int comma 100, and it'll create an array of size 100. In Java, you can't do that. So all of the, quote unquote templates, all the generics in Java have to be types. And so that's like subtle difference, but it can have, again, like some implications on performance. So, all right, that's generics. Why don't you cover garbage collection? So
garbage collection in C++, so there's two kinds of memory, right? There's static and dynamic. There's, I know I need to hold the value of an average of a number of items in a list. So what is the average of all of the numbers in my list, which are heights of various trees in the forest? I like to think of colorful examples. So all the heights of all the trees in the forest. But you don't know how many trees are in the forest when you write your program. You want a program that can work for any forest, maybe a big forest, maybe a small forest, maybe a park, maybe your backyard. I don't know if your backyard can be considered a forest. But anyways, you want to be able to count up and average all of the heights of the trees. So you want a numerator and a denominator, so you can do the sum of the heights divided by the number of trees. That's how you're going to get your average height. So you need these two things, and you need to store the output. So those are your static variables, the variables in advance you're going to need. But then dynamically, you need to be able to say, I'm going to have 100 tree heights, I'm going to have 5 tree heights, I'm going to have 1,000 tree heights. And so in C++, this is done with the new and delete. So when you say at runtime, somebody has to tell you, okay, I'm passing you in a list. And you go, okay, well, how long is that list? Oh, that list is 1,000 trees. Okay, well, then I need to create 1,000 heights item slots. And I go create them. And then I do that with the new. And what it does is, instead of where static memory comes from one place, we won't get into the super big, but like the operating system has one pool of memory for static and another pool for dynamic, which is pretty big. And so it goes and grabs you some random chunk out of this big pool and gives it to you and says, here you go. Here, you can stick all of your trees in this random chunk of memory that I gave you. That's contiguous memory, like it's all in a row, but it could be anywhere. It doesn't give you a guarantee about where it is. And then you get that. And if you can't get it, you're out of memory, and that's what you get, an out of memory exception, because there's no memory for you to dynamically allocate. So you allocate that memory, then you fill it with your numbers, you do your division, and then you need to make sure to free it. If you don't free it, this pool of memory that's for everybody across the whole operating system's dynamic allocations, then they can't use it, and it'll just stay. The operating system will just assume that's always being used forever, and that maybe you really need to keep it there for a really long time, and so it won't go and free it for you. And so if you have a program that runs for a long, and the operating systems will get smart and kind of say, oh, your program's dead, like I can go free it, or try to do various clever things. But ultimately, if your program's running for a long time and you continue to call this function over and over again, you'll keep what's called leaking memory.
Yep.
So the idea in Java is say, well, that's a pain. People inevitably forget to free all of their memory. They don't do it in the right time. You free it too early, and then somebody else uses it, and then Jason goes to read data that I told him that I put there, and in reality it's no longer there, and he reads something else he's not supposed to. So in Java, they get around this by trying to say, instead of this, we'll handle all of the allocations for you. You just go use something. And when you use something, you say new or whatever, and it'll work. But then what we're going to do is use various mechanisms, such things as like reference counting. So how many things do I have that store the address of the data? So I have 5 variables that all point to the same data. Well, Java's virtual machine will keep that data marked for you until there's not, you go 5 to 4 to 3 to 2 as your static functions are ending, as your program's winding down, whatever, and you begin to not need these variables, is called what goes out of scope. So when they're no longer, there's no way your program can need it in the short term, and once that goes down to 0, that means nobody is using that data anymore. Nobody's pointing to it. So then Java can do what's called garbage collect. It can go through and say everything that no longer has anybody pointing to it or using it, I can free.
Yep.
And that works great. You don't have to remember what to free. You don't have to remember who's using what. Java just kind of handles it all for you. The issue is that you don't have control over when that happens. And later they really tried to address this, and maybe even from the beginning, but it's just this complicated issue of if you're trying to do something and you really need it to go now, and Java decides, like, I'm going to garbage collect now, then you kind of are stuck waiting until it finishes garbage collecting because it's a really slow process.
Yeah, because think about it. Java has to go through every object you've made in your entire program, potentially, and say, like, which of these objects do you not need anymore? And that's an expensive process.
Yeah, and so there are great amounts of research have been done to make this better and faster and do all sorts of awesome things to make this. So like even now there's different levels of garbage collection, right? Like a very shallow one. Like, let me just look for things that are really obvious. And if I free up enough for you, great, then I'll stop. But then if like I'm out of memory, like I get to scan through every last, object and really count them all. And that takes a really long time. It can cause your program to pause for seconds or minutes, depending, right, on the amount of memory you're using.
Yeah, and that's why sometimes in Java you'll get I think it's out of heap space, like a memory exception called out of heap space, and that means that you just don't have enough memory to do whatever you're trying to do, like you're allocating too much. But there's another exception that you'll get. I can't remember the name, but I think it's just something really generic like heap exception or heap run exception. What that means is, you're right on the edge of how much memory you're using, and Java, the garbage collector, is spending so much time doing all these like really expensive, like deep algorithms to like clean out objects that like it doesn't have enough time to run your actual program, and so you'll actually get either of these now. But basically, most of the time, the solution is to give yourself more memory.
Yeah. So I mean, this is an interesting feature of Java. It was the first time I remember this really coming into controversy because early on this is a big deal. Like if your program had to sit there and garbage collect, you could really toast. Like if you think about if you're trying to write a game, you have to if you're going to run at 30 frames a second or 60 frames a second, every 1/60th of a second you have to draw something on the screen or else people see it as a stutter. And if Java decides to go garbage collect at a bad time and make you skip a couple frames, you're going to get a stutter and people are going to not like your game as much.
Yep.
So Java also has interfaces. So one thing that you have in C++ that you don't in Java is multiple inheritance. So in C++ you can have 3 different classes, and one class inherit from all those classes and get all of the functions and all of the data objects and everything. And Java said, we're not going to allow that because that causes a lot of problems.
Yeah, so the biggest problem with multiple inheritance is what's called the diamond problem. Have you heard of this?
I probably know it by a different name, so
okay.
Why don't you explain it?
So yeah, I'm going to do my best. This is going to be tough. But so basically the diamond problem is when because of multiple inheritance, you have 2 things that you're inheriting. Both of those have a common parent. And they both override some method foo of that parent. And then you call super.foo. Like, which one should it call? That's the issue. So to try and give an example, which would be really hard, but let's say you have a game object, which is this is your player in some game, right? And game object inherits from like physics object because your player has some physics. He jumps and his velocity changes and things like that. Game object also inherits from, let's say, like player, or player object also inherits from entity, which entity is like includes players and enemies and has things like hit points and like animations and things like that. So you have your player object. It inherits from entity and from physics object. And entity and physics object, they both inherit from drawable. So a physics object can be drawn and an entity can be drawn. And so now your player object calls parent draw, or just calls the draw function. Well, like which one should it call? call, because the physics object has a way of drawing, and the entity has a way of drawing the animations, and you haven't really specified, and the language doesn't really give you a way to say, oh, from these two things I'm inheriting, pick this one, right? Or even worse, someone outside of you calls the draw function, right? Which one should it use? So this is one of these like fundamentally broken aspects of multiple inheritance. There's pretty much no way to fix.
Well, it's a design thing. You have to design it so you don't let this happen.
Yeah, you basically, that's exactly right. You cannot have that in your code. So if you have that situation, you just have to hope that the things you're inheriting from, that you have access to that code and you can fix that. So like if physics object was someone else's library, like the Havoc physics engine, and like the entity was part of like some like the source engine from Valve or whatever, like you couldn't inherit from both of those at the same time without causing the diamond problem. So Java gets around that by using interfaces. And so the idea here with interfaces is you can only have one parent. Like you can only have one-way inheritance. You can't have multiple inheritance. But they understand that, you might want to do, like the example I gave, you might want to have, like an abstract physics object for all of your players and an abstract drawable object for all your players. And you want the players to inherit both of those. So Java adds this thing called interfaces. And interfaces they're not allowed to have any code in them, and all of the methods have to be virtual. But because of that, they get around this diamond problem because you don't have any...
There's no code to be ambiguous about.
Yeah, exactly. So, if you have 10 different interfaces and then you have your parent and you call the draw function only exists in one of those 11 objects, right? Because the rest are all abstract.
So Java also has checked exceptions. So C++ has later come to have exceptions and tries to have exception handling, but Java really kind of just out of the gate did that. Like, we're going to have exceptions, and you can throw an exception in your code, and then code that's calling your code can check for that exception and handle it, or allow the person above you to handle it.
Yep. And
kind of really do this as a way to say what happens when something goes wrong in your program, which is important as a programmer, and we can't keep going into deep on all of these, but or we'll make you here for like 4 hours.
Oh yeah, it's
listening
true.
to us. But it really is important as a programmer to think about not just when things go right, but what happens when things go wrong. And I think too often as programmers we forget to think about that in advance. We always just assume it's the happy, wonderful pony and rainbow world, right, where everything magically works, and we don't spend enough time handling what happens when things don't work.
Yep, and Java will actually force you to catch an exception. Like in C++, you can always just not catch things, and eventually, it'll just cause your program to crash. But in Java, it'll force you to do something about it.
You either have to catch it or you have to throw it again. So you have to say, I'm going to catch this thing, or I'm telling the person above me that they have to catch it.
Yep. Yeah, the only way you can actually, it's not even really a crash, but the only way you can like halt your program is by throwing the exception all the way up to main and then throwing it through main. And then you'll actually cause your whole program to halt. But in C++, unless you do something special by default, you're going to kill the program with an exception. So yeah, we should probably blow through these strengths and weaknesses here because we are.
So we talked about platform agnostic. Java's got huge community support. There's lots of people. Many big companies use Java.
Tons of libraries and anything you could want.
Yeah, example code, support forums. It's great.
Yeah.
Weakness. It used to be speed. Java used to be slow, and that was probably fairly true in the early days. Now, it depends on what you're trying to do. It may or may not matter.
Yeah, I honestly have not seen it matter in anything I've done recently. But yeah, I actually wrote a graphics engine in Java way back, and speed was an issue back then. But now it's just...
Yeah, and that's both because computers got faster and also Java got more optimal, more optimized.
Yep.
So hardware abstraction. So platform agnostic was a pro. Hardware abstraction, you don't have a lot of insight into what your hardware is really doing.
Yep.
So it makes certain kinds of programs very difficult or impossible to write.
Yeah, and you can't, for example, you couldn't talk to the Connect or something, right, in Java.
Unless somebody else wrote a library that interpreted that for you.
Right, exactly.
Which we can't get into how you do that.
Yeah, let's get that. But yeah, you'd have to write something in C to talk to the Connect, and then talk to that in Java, basically.
Yeah.
So the other weakness is it forces you to be object oriented, which is a strength but also a weakness. It's not doesn't let you be functional. Like in the case of C or C++, I can do function pointers. I could pass functions around. If I wanted something like MapReduce, for example, I could pass a map function to MapReduce, and that kind of makes sense. It's like here's this pointer to this block of code. In the case of Java, if I want to use like Hadoop or MapReduce or something like that, I have to create like this map object that has just like doesn't have anything but a function in it. And so it's sort of it's not that big a deal, but just knowing that like you have to do things in an object-oriented way, that could be a weakness.
And that's a limitation to certain people. Certain times it can be frustrating, but of the language, not of the virtual machine.
Right.
Because when we talk about other languages in the future, other languages are purely functional and implemented on the same virtual machine that Java uses.
Yeah, totally.
Foreshadowing.
Yeah, exactly.
So ta-da. I like Eclipse for editing my Java code.
Yeah, Eclipse is great. If you use NetBeans, that's good too. I used NetBeans for a few years. NetBeans used to be way superior to Eclipse, in like the early 2000s. But now I think Eclipse is almost universally better. There's still some diehard NetBeans people out there, but they're both great tools. And,
you really just throw it down, man. You just lay it down. This is better, and then you're just inviting the hate mail.
Yeah, I'm sure I'm gonna get flamed for that, but I think they're both great tools. You can do great stuff.
And there's many other ones as well. You can always edit in VI and.
Oh yeah, there's that too. But yeah, there's even more IDEs like what was it, Bluebird or something? I used BlueJ.
Okay.
Yeah, that was one that I used in college. But
yep. Yeah. So Java is used for almost everything except for applets. I see applets now, but kind of not a very great experience anymore.
Yeah.
But server side. Java is used heavily.
Yep. So if you ever heard of Tomcat or Java Server Pages, JSPs, or any of that, that's all Java.
Now that's different than another way that people write Java for the web, which is like the Google Web Toolkit.
Right.
Or other such, which is you write Java code and run it through a compiler that generates JavaScript for you.
Yep. Yeah, so that's pretty wild, right? So you actually can do client-side Java code using Google Web Toolkit, and I've done a little bit of that. It was okay.
I've never really done it, but what I understand is that Google used that to do Gmail, right? So early versions of Gmail or something were done this way, or to try to do stuff similarly, is why they developed this and kind of released it for other people to use, because it turned out they wanted to make the web a better experience.
Yeah,
and
totally.
So that you can write Java code, which you're used to writing, and it's kind of high level, but then it kind of spits out this JavaScript, which may not be super readable for a human, but will work, and your browser knows how to interpret it.
Yeah, totally.
We also talked about using it for Android.
Yep. If you're doing Android, you're almost certainly writing Java.
Yep. Jason mentioned Hadoop.
Yep. Hadoop's
so for big data as well, which we've not really talked a lot about big data.
Yeah, maybe we should do a show on big data. That would be great. That's awesome. We should do that. We're going to add that to the list.
So the ever-growing list.
It's on the priority queue.
We got a couple of good, excellent listener feedback. So we have some emails we need to respond to as well. Some people have emailed us and said some nice comments, given us reviews on iTunes, showing us the love.
Yeah. Thanks, guys, for doing that. It's been awesome. We're definitely going to keep the show going.
Yeah, so. we know we're not being as on the regular frequency as we're supposed to, but we're really trying. We really want to keep it going.
Yeah, I think that, we had a little bit of a hiccup with sort of we got situated. We have a new recording studio.
Yeah.
So that took a little bit of getting used to the move and everything. But yeah, we should be able to.
We just got to settle back into the groove, and we should be back on a better schedule.
Yeah, totally.
So that's all I got, man. Till next time.
Yeah, have a good one. This is action-packed episode here.
Talking fast at the end.
Yeah, totally. So have a good one, guys, and we'll see you in the next episode.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.